In this video, we are going to identify domain and range from continuous graphs. Now, continuous graphs are graphs that are not just coordinate points. Okay, they can include line segments, lines, any kind of shape that doesn't just have a point, so includes decimals and fractions. So before I get into domain and range, I usually like to look at my graph and determine what are my furthest points or furthest places to the left and the right. So I can see that the furthest point to the left of this graph is at -5, +2. My point over here is at 3, -6. Okay, so when I am discussing domain is my x values. So because I labeled these, I can clearly see that my x's are going to fall in between these 2 points. They start at -5 and they're going to go to 3. Okay, I can write this as a compound inequality. So I have my braces, so x such that, and my x values are going to be in between -5 and +3. So if you remember from last unit, okay, when we're writing compound inequalities, we have our smaller number on the left, bigger number on the right, and it should be some form of less than. So because this is a closed circle, it's going to be less than or equal to. Okay, if it was an open circle, it would just be less than. Okay, I'm going to use the same concept when finding range. So range is my y values. And again, because I've labeled, I can see that my highest point is at 2 and my lowest point is at -6. So that means that my y values are going to range from -6 to +2. And again, I always want to put my smaller number on the left and my bigger number on the right. Okay, let's go ahead and let's look at the second graph. So I notice that I have arrows here. Okay, so these arrows mean that I am going in this direction. So I am going to the left and I'm going down. And again, I'm going to label this with directions because this is not a clear coordinate point. This graph, these arrows mean that this graph is going to continue forever and ever all the way this way. It's going to get wider and it's going to continue down. So this arrow means I'm going to the right and I'm going down. Okay, again, this is kind of continuing this direction and it's going to keep going down. One other important point is this point right here. Okay, and that's at -5, 7. And that is important because that is the highest point on my graph. My graph doesn't go anywhere above that. Okay, so let's talk domain. Domain is my x values. Another thing that you can think about when you think about the x-axis, okay, and I'll highlight the x-axis. The x-axis is the direction of left and right, okay? It's a horizontal line. So when I'm looking at the direction here, left and right has to do with my x values, my domain. Okay, I'm going to cover all the x values all the way to the left of this graph and all the way to the right. Okay, and everything in here in between. So if I see all the way left and all the way right, that means I'm including all real numbers. Okay, and we can write that as x such that x is an element of all real numbers. Okay, so now let's talk about range. Range has to do with our y values, and our y values have to do with our y-axis. So when we think about the direction of y, you can think about that direction in terms of up and down. So I can see that I'm going all the way down, but I'm not going all the way up. I do have a highest point on this graph. So my y value is 7 at the highest point on this graph. So if I'm including 7 and I continue to go down forever, that means that my y values are going to be less than or equal to positive 7. Okay, and let's look at this next graph. This is the curve. Okay, so again, I'm going to go ahead and I am going to label this. So even though it is a slight, it kind of looks like it's flattening out, this is actually a slight incline down. So I'm going to label this. Arrow is going left and down. Okay, and then as you can see, this is going right and up. Okay, so let's look at domain. Domain is x values, which have to do with left and right direction. So if I'm going all the way left and all the way right, that means that x is an element of all real numbers. Our y has to do with range, or range has to do with y, and the directions of up and down. So if I'm going all the way up and all the way down with no restrictions, that means that y also includes all numbers, and we write that as an element of all real numbers. All right, let's just do a few more of these. Okay, this is a discrete graph, okay? So this is not continuous. So when we do not have a continuous graph, that's where you list the actual values, okay? Which you did on day 1. So our x values are going to include, and this is when we list our numbers from left to right, or I'm sorry, smallest to largest, and we don't repeat the values. So I have an x at -6, -3, 0, 5, and 7. And then my y values, and there should be an x equals in there as well. That's going to be at -4, -3, -1, and +4. And I'm not repeating the 4, even though we have 2 y values at 4. Okay, so these two graphs are continuous. So this is not an arrow, it's a coordinate point, so I'm going to label that. That's at -5, -5. And this, again, is not an arrow, it's a coordinate point at 6, 6. So domain has to do with my x values, and my x's are going to range from -5 to 6. So this is a compound inequality, so x such that my smaller numbers on the left, bigger numbers on the right, x is in the middle, and because they're shaded in, it would include or equal to. When I'm dealing with range, my range is my y values, and my y's are going to range from -5 to +6. There you go. Okay, last one. All right, we have a ray here. We have an open circle and an arrow. So I'm going to label this point. This is at -5, 1. And then whenever I see an arrow, I'm talking direction. So this is going to the right, and it's going up. Okay, so domain is our x values. So I can see my x values, they're continuing all the way to the right, but not all the way to the left. So they start at -5 and they go to the right. So anything to the right, we can say our values are increasing, they're getting bigger. So x is going to be greater than -5. And this is an open circle, so we would leave it as just greater than. Okay, for a range are our y values. So we know we're going all the way up, so our values are increasing, so that indicates a greater than sign. And they do have a lowest point though, so our lowest y value is at 1. So this would be y such that y is greater than 1.